This is for all my students, both Math 8 and Algebra 1. Since Algebra 1 you probably missed some of these concepts, I want to make sure you have this before going into geometry next year. And then Math 8 students, you are definitely going to see it this year and when you go into geometry in 2 years. So we have some of this is going to definitely be review, but it will all tie together. So the different types of angles, which type of angles have measures less than 90? Well, you know that is acute. So these are angles that are less than 90. And we talk about an angle. An angle is formed when there's two lines that intersect at the same point, which is called a vertex. And then it forms an angle. So acute are angles that have measures less than 90. So I don't know if you want to write angle here. You probably do. But acute angles have measures less than 90. What have measures equal to 90? Well, right angles. And all of you know that the symbol for a right angle is this box here that represents that's 90 degrees. Which have measures between 90 and 180. Well, those are obtuse angles. And those are going to be larger than 90. They can also do this. Make sure you know when they do it like an open V, sometimes that throws people. They don't always have to have a line going horizontally. Have a measure equal to 0. Well, that's a straight angle. If I can spell straight right. Okay, that is a straight line, and that equals 180. Okay. All right, parallel lines. Parallel lines, you know that lines that do not intersect. And parallel lines are always equal distance apart. And I'm going to show you some illustrations because a lot of times, and you guys know in math, there's a lot of codes or symbols that represent what's happening in the problem that people don't want to write out. So parallel lines, they can go like this, they can go like that, they can go diagonal. But you are at a point in your math career that you no longer can assume anything. So let's say we have this line A and line B. One way that they will tell you that these are parallel, you can no longer assume, is to use a notation like this. A is parallel to B. So they let you know in the problem, this is A is parallel, this is like two parallel lines. It doesn't look like two L's, it kind of does, but parallel lines, parallel to B. Or they might do this. If they don't use this symbol, they'll do this. They'll use a filled in triangle. Sometimes, I think most of the time it's filled in. Okay, and so if it's a parallelogram, this will be a filled in triangle, two filled in going one way, two filled in the other way. And what they'll do is this. Well, I'll get into that later. Perpendicular lines. Perpendicular lines that intersect to form right angles. If they're perpendicular, they intersect and they form right angles. And the way they symbolize this is they have usually let you know there's a 90-degree angle. They don't do all four because if one's 90, all the other ones are going to be 90. The notation for this, when they do this, and let's say this is line L and line M, and they'll usually use a cursive. A lot of times they'll use cursive or italicized letters. Most of the time lowercase also. So they'll say line L is perpendicular, this is the perpendicular sign they'll use in their notation, to line M. So sometimes they don't spell out the word perpendicular. So knowing what these symbols mean. Now a transversal is a line that intersects two or more lines. Usually the lines are going to be parallel. Not always, but most of the time that you're going to see it, the transversal or intersecting two or more lines that are usually parallel lines. So for example, if we have these lines, now they don't look parallel, but I'm going to go ahead and say that they're parallel. Let's do the arrows. Say that, you know what, I'm going to take this, well, A, B, and they're cut. I'm going to take this off. I apologize, guys. Hope you did a pencil because I just realized something. All right, and they're cut by a transversal, and I'm going to say that transversal is C. So A is parallel to B, and cut by the transversal C. And they'll write out the word transversal. Okay, so this is going to be important here in a few minutes, what that does, that transversal, and how all these angles are related. Complementary angles. Complementary angles are two angles whose sum is 90 degrees. Okay? And so, for example, if you have this, and we have this is, let's say that's 50 degrees, they'll ask you what this angle measure is. And then you know if that's 40, if that's 90, then you know that's going to be 40. But the complementary angles together add to 50. You might see this at times to where you have them split. And I say, okay, 40 degrees, what's the complement angle of 40? Well, that's going to be a 50-degree angle. So they could be split, they just together they add up to 90. Most of the time they're going to be right by each other. Supplementary angles, also called linear pairs, are two angles whose sum is 180. So supplementary are 180, complementary are 90. Supplementary are also going to be linear pairs. If they equal 180, do you remember up here, a straight angle equals 180. So a straight line will equal 180. So that means for this example, say it's this. If I say this is 130, if that angle is 130, what is the measure of this angle? Well, knowing that these form a straight line, this is going to be 50. So together they equal 180. Now I want to help you remember complementary and supplementary, a couple of ways to do that. I don't know how I thought this or saw this, but I saw this P here, and I just related that P equals 90. P equals, 90. The two P's equal 180. So one P equal 90, that means double that would be 180. You can also do it in alphabetical. So complementary is going to be 90. Supplementary, since that's later in the alphabet, it's 180. And 90 is first and 180 is second when you're doing numerical. So you can think of it either way, but just kind of help you remember which is which. All right, now we are going to look at the back, and we're going to see how all of this is related when you have two parallel lines cut by a transversal. So right here, here's our notation. B is parallel to C, and A is the transversal. So then that lets us know that these are parallel lines, and then this is A is a transversal. When that happens, there's certain relationships with these angles. They are related in a way that you can know a measure of one of them, and then you can find all the rest. So let's look at this terminology. A vertical angle. Vertical angles, they're two pairs of opposite angles that are made by two intersecting lines. Okay. So the two pairs of opposite angles that are made by two intersecting lines. So what this means is, like the angles examples, now first of all, they have the same measure. So angle, now here's also, you guys, this is the angle sign. It doesn't look like a lesson. It's slanted and then a flat. That's the angle sign. So angle 1 and angle 4 are opposite angles. 2 and 3, angle 2 and angle 3 are vertical angles. Angles 5 and angles 8, vertical angles. 6, angle 6, and angle 7 are vertical angles. What's great about these, if you know 5, you know 8. And so those are the same measure. They have the same measure. Another thing, measure. M, lowercase m, equals measure. So when you have the M angle, that means the measurement of that angle. Adjacent angles. Adjacent angles are two angles that have a common side and the same vertex. Oh, and vertex, I should say. And vertex. So now adjacent angles in here, now they don't always add up to a certain number. They're just next to each other. So in this case, 1 and 3, angles 1 and angles 3 are adjacent. Well, angles 1 and angle 2 are adjacent. They're next to each other. And these are actually called something else too you can use for measurement. Angle 2 and angle 4 are adjacent. So the ones that are adjacent, they are right next to each other. They share the same sides and the vertex. Angle 1 and 4 are not adjacent because even though they share a vertex, they do not share a common side. 1, here's the angles or the sides for 1, here's the sides for 4. So they don't share a common side, only a common vertex. Corresponding angles. Now these sometimes can get confusing. These are two angles that occupy the same relative, oh my gosh, you guys, I can't spell this morning. Relative position. Now, in the set of parallel lines cut by a transversal, what that means is typically when you have the two parallel lines and you cut this transversal here, this set of 4 angles and this set of 4 angles, if I cut this out and lay it right on top of this one, which angles would match up? So this angle 1 would match up with 5. It's in the top left corner of that set of 4. So this is the angle 1 and angle 5 are corresponding. Angle 1 and angle 5 are corresponding angles, and they have the same measure. So it's nice if you know measure of angle 1, you know measure of angle 5. So measure of angle 2 is corresponding with measure, or not, well, measure, yes, but angle 2 corresponds with angle 6. Angle 3 corresponds with angle 7, and angle 4 corresponds with angle 8. So what's really nice is knowing those terminology and knowing that they're equal. Once I give you one of them, you can find all the angle measurements. Alternate interior angles. Alternate interior angles. So a lot of times just breaking down the terminology. Now this is the pair of angles that are opposite or on opposite sides of the transversal, but inside the two parallel lines. So if you notice, we have interior and exterior here. Interior angles, all of these inside the parallel lines, these angles are inside. Exterior, 1 and 2, 7 and 8 are outside the parallel lines. So those are the exterior. Now, alternate interior. Alternate interior means on the opposite sides of the transversal. So angles 3 and 6 are opposite. So they're alternating interior angles. And angles 4 and angle 5. Again, those are the same measurement. So angle 3, if you know 3, you know 6. If you know 4, you know 5. Okay. Alternate exterior, same thing. Alternate exterior, except for they're outside. So the pair of angles that are on the opposite sides, still opposite sides of the transversal, but outside the two parallel lines. So 1, 2, 7, and 8 are in the exterior of the parallel sides. 1 and 8, angle 1 and angle 8 are outside. Angle 2 and angle 7 are outside. They're alternate exterior angles. All right, last one for this one. Consecutive, which means it's going to be the same side interior angles. So sometimes they'll just say same side interior. Sometimes they'll say consecutive interior angles. So interior, so you know you're looking just inside. All right, two angles that are on the same side of the transversal and inside two parallel lines. So this angle, so angle 3 and angle 5, and angle 4 and angle 6. Now notice, they're on the same side and they're interior. These two angles together add up to 180. So if you know 4, you know 6 by subtracting it from 180. So you're going to be doing some practice here pretty soon of identifying. So your assignment today is identifying the different angles, the relationships, and then you're going to be given like a number and you can find another angle based on how it's related. Okay? Thank you for listening.